Hey, it's Tate here. This is another C Emacspeak tutorial. So this video is going to be focused on pointers, what they are, how to use them, and all that. We have a basic file here that just has a template with int main and return 0. So I'll show you.
Pointers.c2 c/*l 74% pound / cap. This is a pointer demonstration. Pound include less than stdio.h greater than int main left paren left race
And well, I
r
forgot.
return indent
0.
to return 0 semicolon.
Okay.
In new.
So what are pointers and what do we need them for? Well, imagine a pointer kind of like an address for one of your friends. So if I go to Fred's house and I say, "Hey Fred, do you know where Bobby lives?" And Fred says, "Oh yeah, I know where Bobby lives, 123 Main Street." Well, I can go to 123 Main Street and I can find Bobby. Well, a pointer is that address. It's the 123 Main Street. So it has the same relationship as 123 Main Street does to Bobby. That is the same relationship as a pointer is to a variable. So let's take an example of this. So let's say I create the variable int age equals 21.
Indent to int age equals 21 semicolon.
Okay, so I've got an int age. I've talked about in other videos how to print this variable, so we're going to print it. Printf %d \n
comma n
and give it the
cap
age
matches
variable.
indent to print left paren quotes %d \n quotes comma age right paren semicolon.
Okay, so that tells us print the age variable and then print a new line. Easy. Well, what if we want to print the address of something? So what if I ask, "Hey, age, where do you live?" Well, this is easy. So printf %d \n
n
and then and %age.
matches indent to print left paren quotes %d \n quotes comma ampersand age right paren semicolon.
And in C says, "Give me the address. Where do you live?" And use that instead of what your actual value is. So we're going to save this file.
Cap. Saving file /home/tate/ cap. Documents/described -tutorials /c/pointers/pointers.co3.
Okay, we're going to switch back to our shell.
/documents/described -tutorials /c/pointers *** autospeak 2.
Okay,
clang.
and we're going to compile it.
-00.
I'll have a make file in the zip that's on my website if you need it. But compiling something like this manually is fine. We use clang. -o says this is what I want the file to be called when it is done. And we'll call it
pointers.
Oh, my character echo is on.
Turned off Emacspeak -character-echo locally.
There we go. And then pointers.c.
Pointers 1 warning generated.
Okay, so we got a warning. Now, you might be wondering, why are we getting a warning? Well, this one's very interesting. Basically, how would you explain that? An address is not the same thing as a number, right? 123 Main Street, for example, that's not a person. So think about it in that way. If I say, okay, my friend Bobby, he's a person, his address is not a person, it's an address. So when we print it, we cannot print using %d because %d is for integers. %s is for strings. %f is for floating point numbers with decimals. So what do we have to use? Well, conveniently, you use the first letter, basically. So in this case, s string p pointer. Let's try %p. I'm going to have it read out the error message, though.
1 warning left right pointers.c:7:18:warning: format specifies type quote int quote but the argument has type quote int asterisk quote left bracket -w format right bracket print left paren quotes %d \n quotes comma ampersand age right paren semicolon $.
Okay, so that warning is essentially telling us, hello, are you aware that you're trying to print a pointer and not an integer? So it turns out that if you want to have an integer pointer, that is int asterisk. Asterisk is the symbol in C to say this is a pointer, and we'll see how to use that in a minute here. But let's go back and let's change %d to %p.
Pointers.c to C slash asterisk L 90%. Semi. Right recap E. Right recap matches print left paren E G A ampersand space comma quotes N backslash D percent D backslash.
Okay, so we replace
D.
D with P. And I'll read that line.
Indent to print left paren quotes %p backslash N quotes comma ampersand age right paren semicolon.
Okay,
Cap
save
saving
that.
file slash home slash state slash cap document slash described hyphen
And then we'll
tilde
go
slash
back.
document slash describe.
Okay,
W.
that's okay. And then we will run the last command, which you can do on Linux with exclamation point, exclamation point.
Clang hyphen o pointers pointers.c.
Okay, so that compiled. You'll know it compiles because it won't say like one warning generated or something like that. Okay, so pointers.
210x7ffE2c9f with $4.
Okay, so that was kind of crazy. So let's go up. Let's read it one line at a time.
0x7ffE2c9f with 4. 21.
Okay, so it prints 21.
$./pointers.
Okay, that's where we ran the command.
21.
21, so that's the age. And then there's this. There's this nonsense.
0x7ffE2c9f with 4.
Okay?
X0.
0x
7 F F E 2 C 9 F B E F 4.
Okay? What that is that's hexadecimal. By default, pointers are printed in hexadecimal notation. So instead of going from 0 to 9 and then 10 is 1 0, it goes from 0 to F. F is our equivalent to 15. The reason for this is basically that computers know binary, which is ones and zeros, and converting between binary and base 10, which is what we use every day, that's really difficult. Right? In your head, if you're a human and not a computer, calculating the difference between binary and decimal is very difficult. But binary and hexadecimal, because they share the same power, is power the right word for that? I don't know. Anyway, you know what I mean. 16 divides into 2 evenly, whereas 10 does not divide into 2 in the same way. Does that make sense? It probably doesn't. Okay. Anyway, point is, these hexadecimal letters are easy to work with because each hexadecimal letter directly can be translated into 4 binary bits. So for example, if I say FF, that is 1111 1111. If I say 0F, that is 0000 1111. Makes sense. The relationship between hexadecimal and binary are more closely linked than decimal and binary. So it gives us a clearer representation if we're trying to read the computer's code more directly. Okay, so it gives us this address. This says, where am I? What can I do here? So what can we do with this address? It's not useful by itself, right? Obviously, being able to print the address of a number is not very helpful. So what can we do with this? Well, I'm going to add a couple lines of code, which will show you what the use can be of this. Okay, so let's switch back to our file.
Pointers.c to C/*L indent to.
Okay, and this is going to be after our printf %p. And we are going to set, so we're going to set up a new integer, but this is not going to be an integer. This is going to be an integer pointer. So int asterisk.
Int.
I know it doesn't say the asterisk. Int asterisk, and we'll call this PTR. PTR is a very common abbreviation for pointer in C. Okay,
PTR.
and we'll set it equal to
PTR.
ampersand age.
Indent to int asterisk PTR equals ampersand age semicolon.
Okay, so we're saying create a new integer. It's going to be called PTR, create a new integer pointer. It's going to be called PTR. and it's going to be set to the address of age. Okay, a little bit complicated, but stay with me. So now here's something fascinating. Instead of printing the address of age, we can print PTR. And PTR itself is that address. So let's do that. Printf %p\n, and then we'll put in PTR.
Cap matches print to print left paren quotes %p \n quotes comma PTR right paren semicolon.
Okay, and if we save and run that, you will see that this actually will print the same line twice.
Cap saving file /home /hex tilde /document /describe $20 clan -o pointers.
Okay, so in Emacspeak, if you go up in your terminal, so if I hit my up arrow,
$clan -o pointers.c.
Okay, so it says, okay, that's a command that you ran. If I hit enter, it'll run the command again. So that's how I'm running that command again without typing it all out. Okay, so I've compiled it again.
Pointers.
I can type pointers and hit enter.
210x7 FFDD904A5F40 904A5F4.
Okay, you'll notice that those two last lines were identical. And you'll also notice that it changed. It's not the same address as it was before. The start of it is the same, 7FF, but the rest of it is not. This is because most programs today, most operating systems today, that's your Linux, Windows, Mac OS, have this layer in between. They manage something called virtual memory. And this is so that your program can't say, I see 0000000, and I notice that is where you're booting from. I'm just going to overwrite that with, whatever I want to overwrite it with, and now you're going to boot into some, malware that I've written. This protects each process and keeps everything sort of in its own sandbox so that it can't interfere with other processes running on the system. So because of this, every time you run the program, okay, even if I don't recompile, I could run this, I could run the same thing again.
Pointers 210x7 FFCD6C296B40x7 FFCD6C2.
Okay, and you'll notice, it's the same again. I cut it off because it was taking too long. You'll notice it's the same again, but it's different than the last time I ran it. This is, again, because the virtual memory, and it will actually move where in memory it's being executed each time. So yeah, I hope that makes sense. All right. Well, what else can you do with pointers? Well, here's something fun you can do with pointers. If you have a pointer to something, you can change the original thing. Now, the reason pointers tend to be very complicated, or rather seem complicated to people, is because there's one symbol to do two things. For example, int asterisk says I am creating a pointer of type int, and this, which I'm about to tell you now, called the dereferencing operator, which turns an address back into the original value, that also uses the asterisk. So it can be kind of confusing. So let's see what we can do here.
Pointers.
Okay, so we're back in pointers.c, and we are going to type asterisk PTR plus equals
PTR
1.
Indent to asterisk PTR plus equals 1 semicolon.
And what this does is it says, hey, I have PTR. This is an address. This is our 123 Main Street. And I want you to go there, find what is there, and increase its value by 1. So what happens if we print age again? Do you think that it's going to be 22? Well, if you do think that it's going to be 22, you would be correct. So printf %d \n
comma n
age
cap indent to print left paren quotes %d \n quotes comma age right paren semicolon cap saving file
Okay, so
/home
we
/hex
saved it.
cap tilde /document /describe.
Okay, and we are going to compile.
Search back mark save.
Okay, so what I did there is I hit Control R, which does a reverse search instead of a forward search, which is Control S. And I typed in Clang, hit enter, and it took me to the last time I typed Clang in my shell. And then I hit enter again, and that runs the whatever line I have highlighted, it runs it as a command. So I did all of that in a couple seconds, but that's the process to turn it from some command I ran 5 minutes ago, and now I can run it. So Control R.
Search backward, :
Clang, C-L-A-N-G. Okay. I know it doesn't say anything, but if it matches, you'll be able to know if you hit enter, because it'll say mark saved where search started.
Mark saved where search started.
Okay, perfect. So it found it. If I look for something that doesn't exist, so let's say I look for
search backward, : TL and no pointers.c.
See? It makes that little snare drum noise, and that says not found, can't find.
Mark saved where search started.
Okay, so it will still say mark saved where search started, apparently, but it will make that little drum noise to tell you, nope, it doesn't match. Okay, so I can hit enter because I'm on a line that is Clang, as we can read here.
$clang no pointers.c.
Okay, and I can just hit enter and it'll run that command again. Perfect. So let's run pointers again, and we'll see 21, the address using &age, the address using PTR, and then the new value of age after I change pointer. Now, why all this complexity? That will be explained when I talk about functions. Functions can use this to increase their efficiency, and I'll show how in one of those videos. I'll have it linked somewhere.
21 0x7 FFD7B1D74B4 $22.
Okay, so the last line is
22.
22.
0x7 FFD7B1 0x7 FFD7B 21.
Okay, and then there's those two long addresses that we don't care what they actually say.
21
Okay,
0x end of
so this is the basic concept of pointers. It's an address. It is, hey, where do you live? Where are you in my memory? And then also remember that there's this virtual memory layer that we don't have to worry about, but that's why it will show up as a different location every time you run the program. All right, hopefully that makes sense. Hopefully I can get, I want to get a video out about functions, because functions are the primary reason that we're using pointers. For example, you know what? Before I go, one more thing. This is actually how we can use scanf. So do you remember scanf? If you don't, I have a video on scanf. I shouldn't say remember, but if you've ever used scanf in C, this is essentially what it does, is you pass it a pointer, and then scanf can change the value of that pointer from inside itself. Okay, so watch this. I'll show one more thing here.
Pointers.c2 C/*L 93%.
Okay, so we're going to create a new line.
Line 12.
Line 12, okay. And we're going to say printf.
G.
And we're going to say hello.
OLLEH.
What is your age?
Age. Invent to print left paren quotes. What is your age? Quotes right paren semicolon.
And then we are going to use scanf %d.
Copy.
And we are going to pass it &% age.
Invent to scanf left paren quotes %d quotes, comma, &age right paren semicolon.
So that's telling scanf, look for a whole number, an integer, and put it into age. Now, the reason we can't just pass age to scanf is because age is just a number. If we pass age to scanf, it's just going to get the number 22. What's it supposed to do with 22? How is it going to set age to this new user input if all it has is the number 22? But if we give it the pointer, if we say, hey, change the thing at address 123, move a new person into address 123. That would be the human equivalent, is switch ownership of 123. That's not exactly right, but move stuff. Move stuff to address 123. That's essentially what we're doing. Here's the address. Go paint the house. Go move the person. Go demolish the building, whatever it is. Okay, and then we will printf again. %d \, and we'll do after user input %d \n age.
Invent to print left paren quotes. After user input : %d \n quotes, comma, age right paren semicolon.
Okay.
Saving file
So
slash
we've
home slash
saved it.
text tilde slash document hyphen mark saved where search started.
Okay, we're going to run Clang again. And then
Pointers.
we are going to run pointers.
210x7 FFC 05C76054 0x7 FFC 05C76054 22. What is your age? Colon.
Okay, so it had 21, it had the 2 addresses, it had the 22, and now it's asking us what our age is. So if we say 55,
after user input, colon, $55.
Okay, so 55, that dollar sign is only said sometimes. The dollar sign is just you're back at your terminal prompt, so you can ignore that. Okay, so now we're able to change this by passing the address to a function. So that it's called passing. So you pass variables or pass parameters, and that's what we're doing with scanf. We're saying %d, so look for some integer, and then we're giving an %age saying, hey, here's the address. When you get whatever you get from the user, put that in this address. Hopefully that makes sense. I will be coming out with something on functions pretty soon, and stick around for that. I'll link it in the description.